Okay, now with this one here, we've been given the derivative here, and we've been asked to draw the original function. And so these are a little different, but it's a matter of working through the process again. So we've got to start here by drawing the sign diagram of the derivative and the second derivative. Now the first derivative is actually just really easy because we just read it off the graph. So that's a and b there, and that's my origin there. So if I'm doing my derivative, then it'll be 0 and b, then my two zeros to the left. 0 is minus, then it's plus, then it's minus. So that's my derivative. Now for my second derivative, we've got to use the stationary points of the graph as zeros. So if this is f double dash of x, well, I've got a 0 of that at a, and then use increasing or decreasing regions of my derivative. So here to the left of a, it's going up, so my second derivative will be positive. On the other side, it's coming down, and so it will be negative. Okay, now we use the sign diagram of f dash of x to determine the type of stationary point. So here on my derivative, it's going from negative to positive, so it's going from coming down to going up, so that'll be a minimum. On the other side, it's positive to negative, so it's going up to coming down, and so that will be a maximum. Okay, alright. Now, we can mark our stationary points anywhere on the graph, provided that we're not told anything about the original function. We don't actually know where, so we've got a maximum, a minimum at 0 and a maximum at b, but we don't know where that occurs. Now in some cases you will be told, and in some cases you won't. Now in this case we were told, this was an exam question, we were told that it goes through the origin. So when x is 0, our minimum must occur at 0, 0. Now b has got a maximum, and there's no other turning point. So the graph must be going up to some sort of maximum here. Now, also, what else do we know? Well, the sign diagram of f double dash of x tells us the kind of curve we've got. So it's going to change curvature at a, and it's going from convex to concave, which is kind of what we expect. So we've got a minimum here. So it's going to be convex all the way to a, and then it's going to be concave all the way from A to B, where it occurs at a minimum, and then it's going to come down like that. And that is your full curve, and that's the original function. So your sign diagrams of f dash and f double dash are going to be very important. Now for asymptotes, well, again, let's start by drawing first and second derivatives. So f dash of x and f double dash of x. Now f dash of x does have 1, 0 at about a half, or minus a half it should be. And then, okay, so to the left of minus a half, well, it's got a vertical asymptote of minus 3. And on both sides of that, it's going to be positive. And then it's also got a vertical asymptote at 2, and on both sides of that, it's going to be negative. Now the second derivative, where we look for where it's increasing and decreasing. Second derivative, well, there's no stationary point, so there's no 0, but there will be a vertical asymptote at minus 3 and 2. Okay, so the left of minus 3, it's going up, so it's positive. Between minus 3 and 2, it's coming down the whole way, so it's negative. And then here, after 2, it's going up, so it's positive. Okay, alright. So the horizontal asymptotes, if the second derivative is positive as it asymptotes, then the asymptote occurs above the line. So on my original function, if the second derivative is positive, then it will be asymptoting above the line. So here, second derivative is positive, so the original function will be asymptoting above my x-axis. Okay, if the second derivative is negative, then it occurs below the line. But that doesn't occur on this, so both are positive. Second derivative is positive at both ends, so it asymptotes above the x-axis. Now vertical asymptotes, if the second derivative is positive near vertical asymptotes, then the graph will be at really high positive numbers. In other words, it'll go up to infinity, positive infinity. And if the second derivative is negative, it'll go down to negative infinity. Okay, alright, so vertical asymptote at -3. On this side it's positive, so it'll be going up to really high numbers like that. So it'll look something like, whoops, let me just get back onto drawing. It'll look something like that. Okay, on the right of -3, it's negative, so it'll be going down to really low numbers. And on the other side, it's also negative, so it will be going down to really low numbers there as well. Now, we also said that zeros get converted to stationary points, and if we have a look here, we're going from positive to negative, so it'll be a maximum there. Now, we don't really have enough information to tell us where the maximum is, but let's just put it there. And so we'll get a function that looks something like that. If you're not told where a particular point where the graph goes through, then you just have to put it anywhere where it seems reasonable. Now then, on the right of 2, the second derivative is positive, so it'll be at really high numbers. It'll come down and it will asymptote above the x-axis. And I probably should just add in these vertical asymptotes here, just to indicate that I know they're there. And that's this other process done.